TK,
What's up, man?
have you hit the gym lately? With the remodeling going on, apparently I haven't gotten any gains, bro.
No, unfortunately, since the gym's been closed, the gain factory's been at an all-time low.
Yeah, lately I've only been able to do push-ups and sit-ups ever since the remodeling began.
You know what, man? I'm tired of not having an order workout. We're engineers. Let's design a pull-up rack ourselves.
Yeah, that's a good idea, bro.
Alright, so we need to start by deciding what shape to use. I feel like we could use a round HSS for the pull-up bar and a rectangular HSS for the frame.
I agree. If we turn to table 2-4, we could use that to determine the preferred material grade. In this case, it'll be ASTM A500 grade C. So that gives us FY of 46 KSI for the round HSS and 50 KSI for the rectangular HSS.
Alright, so we'll go with the ASTM A500 grade C. I'm thinking we can make the two columns 7 foot tall and the beam across 3 foot.
I agree, but if the round HSS member is slender, it will also be susceptible to local buckling. So we better check the slenderness ratio using chapter B in the manual. And also we have to make sure that the columns will be able to hold our body weight.
Exactly! We want our station to be efficient and not waste a bunch of materials. Let's calculate the shear moment diagrams on the beam and get the reaction on the columns.
Well, I'm looking at table 3-14 for flexural strength of around HSS. Since the AISC manual is for building large structures, even the lightest sections will still hold our weight. It looks like we could find some smaller tubes available and then calculate the required member properties manually using chapter F. Luckily, we can always use the equations from the spec if we don't have tables to calculate the design capacities.
Well, we don't want to go too small or it won't feel right in our hands.
Let's go with the HSS 1.660 by 0.140, which will give us phi-mn of 1.05 kip feet. And since there is no superscript F, we don't have to consider local buckling.
Okay, so how do we want to fix these elements together?
Let's pull together rectangular HSS to create the frame. And then on that, we will put steel plates to act as a cradle to hold the pull-up bar.
Sweet! Let's get to calculating the rest of the limit state so we can have our own workout station.
I think AISC table 4-3 has what we need for the column loads. And again, since our loads are light compared to structures, let's try the smallest section available, which is HSS 4x2/1/8.
Okay, so if our column is 7 foot tall and we assume it's to be braced at the top and bottom for weak axis buckling, that gives us a capacity of 27.7 kips per column. And that's way more than we weigh.
All right, that should work. Let's go build this thing.
Alright, let's get some practice welds. I'll be honest, Brandon. I don't know if we can successfully weld this thing.
Yeah, I don't know either.